This video is over Lesson 88, Review of Proportional and Non-Proportional Relationships, and it is for my pre-algebra classes. So ladies and gentlemen, you can see that I've already got a lot written out here. I'm actually going to move it up just a little bit for you there. And I highly recommend that you go ahead and just give the video a pause, copy down what you already see on the screen, and then you can kind of take it easy and relax as we talk it through. All right, so here we go. So this is a review of proportional and non-proportional relationships. Just so you know, as we move into the future, proportional relationships are going to get a special name. They're going to be called direct variations. So proportional relationship is a direct variation. So there are four main ideas that you need to understand about proportional relationships or direct variations. So first, as one value changes by a factor, the other changes by the same factor. So if we take a look here, if I take my x value here and I go from there to there, we're taking 1 and multiplying it by 2. So then likewise over here, when I go from 3 to the next y value, we should also be multiplying by 2. And we are. 1 times 2 is 2, 3 times 2 is 6. If I move from here to there, we have to take 1 times 3 to get that 3. So it should be 3 times 3 to get that 9. And that does certainly work. Or for that matter, if I were to go from the 3 here to the 24, well, it's 3 times 8, that would give me a 24. So then this 9 times 8 should give me my 27. And sure enough, that works. And we could do any combination here. We could say 2 times 12 is 24, so 6 times 12 should be 72. Yes, it is. I could also go work my way backwards. I could say 24 divided by 24, since that's related to multiplication. Division is related to multiplication, so 24 divided by 24 is 1, so 72 divided by 24 should be 3. And it turns out any way you want to look at it, this works out. So this is proportional. Over here, if I go from 1 to 2, I'm multiplying by 2. Well, so 1 times 2 is 2. So over here, I should also be doing 3 times 2 is not, but 3 times 2 isn't 9. And since it isn't 9, that means that this is non-proportional. I don't even have to look at the rest of the relationships. If one of them doesn't work out, it's not proportional or non-proportional. Number 2. We need to know that all pairs of values form equal ratios. And that fits into the definition of a proportion. A proportion is a statement that two ratios are equal. Well, here it's all ratios are equal. And if ever we get something that's undefined, we're just going to ignore that. So if the x value is 0, since that's going to be our denominator, that will result in undefined, we don't worry about that. That's something we just kind of skip over. So if I've got this table of values here, our ratios are always going to be y over x. So this would be 4 over 1. Here I would have 8 over 2. This would be 12 over 3. And the last one would be 16 over 4. And now if I go through and I simplify those, 4 over 1 is 4. 8 over 2 is 4. 12 over 3 is 4. 16 over 4 is 4. And since these are all equal, this sure enough is proportional. If we look at our other table of values, I would have 0 over 0 here, 1 over 1, 4 over 2, and 9 over 3. Well, 0 over 0 is undefined, which isn't a problem. We're just going to skip over that one then. We're not going to worry that. So we're going to look at the rest of them. Do the rest of them have equal ratios? So 1 over 1 is 1, 4 over 2 is 2, and 9 over 3 is 3. And so because these are not the same, this would be non-proportional. This would be a non-proportional relationship. So number 3, the graph is linear and goes through the origin, 0, 0. So all proportional relationships have linear graphs, means they make a line, and they go through the origin, 0, 0. So a quick look at the graph, we should be able to determine whether or not it is proportional. So this first one, sure enough, is linear, and it goes through the origin, proportional. This one goes through the origin, but it's not linear. So this is non-proportional. Next up is linear, and it goes through the origin, so proportional. And then our last one is linear, but it does not go through the origin. So this would be non-proportional. And then number 4, proportional equations always have an equation of a certain form. And that certain form is y equals kx. We've actually already seen k. K is calculated by taking a y value over an x value. However, we're going to put it down here as well. So y equals k over x, where k equals a y value over an x value. So if you end up with an equation like y equals 2x, well then 2 is your k, and that's proportional. If I end up with something like y equals 2x plus 3, well, this equation, this formula, has no plus 3, no plus anything. And so that would not be of this form, that would not be proportional. So just y equals something times x. That's it. As long as we have that, that's proportional. Now, on my dry erase board here, I'm going to make one little point here about this. Let's say you had something along the lines of y equals x over 5. So remember that fractions mean division, so this is really y equals x divided by 5. And then we need to also remember that division is really multiplying by the reciprocal. So y equals x times, and the reciprocal 5 is 1/5. Well, if we do a little commutative property of multiplication, switch those around, we get 1/5 x. So it turns out that if you have a x over a number, that actually is proportional. It just means that you have a fraction for k. And so kind of the shortcut of all this is that if you have a variable in the numerator, you can imagine your variable just sliding off the top and landing next to the fraction. Now, what does that empty space get filled with? A 1. So y equals 1/5 x is the same as y equals x over 5, and therefore is proportional. And that, ladies and gentlemen, is the end of our lesson.